Welcome back, physicists. We're going to add a quick little video here on polarization. I did not put it in the notes, but it is on the test and midterm. So polarization is really important because it's one of the first proofs that light is a wave. So on the screen you can see some different kind of polarizers. They're mostly filters. Probably you own a pair of polarizing filters, i.e. your sunglasses. So let's take a look at how they work. So polarization, like I said, was evidence that light is a transverse wave, because light, we know, is being perpendicular. It has an electromagnetic wave which vibrates perpendicular in all directions to the wave motion. We've already learned that. So if we simplify that into this simple right triangle or right angles here, you can see 90 degrees. When the waves come through, you can actually polarize them. So here's what that means. So polarizing means you take this light which is coming in perpendicular, this wave, and you put it through a filter which only has a one plane, and when the light goes through, it blocks out part of the wave, and you only get this polarized light, which means it's always vibrating in one direction only. So unpolarized can be in many directions, polarized is only in one direction. So you might think, oh, how is this useful? Well, basically what it does is it takes away a lot of the glare, and it also helps us see different parts of objects in terms of, for instance, you'll see in a few seconds, stress. You can look at parts that have been failing, and you can actually see different things because the light has been polarized. So on a polarized light, we said vibrates in one plane only, and only transverse waves can be polarized. So sound waves cannot be polarized. If you go back to this picture here, if you put a mechanical wave or a sound wave through this filter, it's just going to come out on the other side. Hasn't changed. So this is one evidence that light is a wave, and not only light but all transverse waves. Everything on the electromagnetic spectrum, all the way from gamma rays to radio waves, can be polarized because they vibrate in this perpendicular motion. So if you look on how this works here, on the left here you have this beam coming in, and the light's in all different directions perpendicular, and then it goes through this polarizing filter and it makes it polarized, so vertically polarized. And then if you make it go through another filter, but you turn it 90 degrees horizontal, now the wave can't get through because it's vibrating vertically, and what happens is you get nothing. So if you look over here on the right, you can see this person is turning two polarizing filters, and they're actually canceling out all the waves by switching the direction of the filter itself from vertical to horizontal. You can usually do that with sunglasses. So if I put on a pair of sunglasses here, and if you can do this on your computer screen, and then I just turn my head, my computer screen goes from dark to light because the computer screen is polarized, and so my glasses are also polarized. And if you change the angle or the direction of the filter from vertical to horizontal, you can block out all the waves. So it's kind of cool. So you can probably not see my eyes at all, and then maybe, I don't know if this is going to work, but if I turn this vertically, you might be able to see light coming through. I can. And then if I turn it horizontally, I can't. I'm not sure if you can pick that up, but all you need to do is have your own pair of sunglasses, and you can literally see this yourself with any surface. So things that polarize light besides filters are just like computer screens, we said, reflections off of mirrors, not mirrors, I'm sorry, of water, off of glass. Anything that reflects light polarizes it. So the picket fence analogy is very, very popular with explaining polarization. So the picket fence shows that when the pickets of the fences are aligned vertically, the vibration can make it through the fences. But when you turn one of the fences horizontally, then the wave gets stuck and you can't come through, and that's when it goes dark. So I've been able to show this in class, so maybe if we come back I'll show it to you. I forgot to mention another example of this polarization is in 3D. So 3D movies use polarization also. So do all your LCD screens that you have on your phone, cameras, everything you own uses a polarizing. So like I said, you can look at your phone, and if you do with polarizing sunglasses, you can turn your head and it can basically go black. Same thing with gas pump lights. If you look at the LEDs, if you're pumping gas, you want to see the price. I used to have this problem with my sunglasses on, you can't see the screen. Turn your head, it goes back. Turn your head, it goes away. So basically what you're doing is you're just changing the direction of these filters. So your computer, your phone, everything has polarizing filters, so you can help see the LEDs. So you can just try it. Just put on your polarizing glasses, look at your phone, turn your head, it should go black. And you can take a look. Polarizing filters are useful for fishing, for instance, in sports. driving. People that are driving a lot on the road, troopers, state police, they don't want eye fatigue, so they wear polarizing glasses because it takes out the reflections. So this is a non-polarized view with reflections. This is a polarized view without reflections. So like I said, in fishing, you can see the fish in the bottom of the pond or stream or wherever you're fishing. And then in automobiles, it takes out the glare off the road, it takes out the glare off the windshield, and it helps your eyes get less fatigued. So non-polarized, very fuzzy, hazy, and then polarized, it clears it right up. And in photography, in your cell phone probably has a polarizing filter option where you can actually clear up the sky. So non-polarized, polarized, again, it makes for a better photograph, polarization. A really cool thing to do is look at your automobile with your polarizing glasses, and you might have to turn your head and you can actually see the safety glass. So this is top view is just a regular car window without polarization, and this bottom view is with polarization, with polarizing sunglasses on. Just turn your head and you can kind of see all these little squares are what we call safety glass. So if this window was to break, it breaks in little chunks. It doesn't break in sharp shards like maybe your house windows would, which are very dangerous. I mentioned polarization of light is used to look at objects to see for stress. We do these in class. We have just a tape dispenser here, and all the manufacturing of the dispenser shows where there's been a lot of stress on this plastic. So the purples and these dark reds show lots of stress. We're looking at this through polarizing filters, which I have in school, lots of them. So here's glasses, regular glasses through polarizing filter. Here's a plastic glass. You can see when they extrude these, you get a lot of stress. And normally I could twist this for you in live, and you can see the stress build. So I guess that's all for polarization. Remember, the most important thing that you have to remember about polarization is it's one, evidence that that light is a wave, because if light wasn't a wave, this would not happen. And the other thing you have to remember about polarization is that all transverse waves can be polarized and no mechanical waves. So all waves can, except for sound waves. Okay, I guess we'll stop there, and there's a few questions on your homework. If you get stuck, we're going to have a Zoom review on the homework. Polarization will definitely be on the midterm, so just a few quick questions.